Hi, thank you for joining my lightning talk today. My name is Ryan Harp, and I'm a postdoctoral research fellow at the Institute for Sustainability and Energy at Northwestern University in Evanston, Illinois, in the United States. And today I'll be talking about using climate to increase the lead time of a malaria early warning system in Mozambique. So Mozambique reports about 8 to 10 million cases of malaria each year. And because of this, they developed an early warning system which uses observed case counts and observed weather conditions to try to forecast future outbreaks of malaria. The goal of this project was to increase our understanding of how climate variability affects malaria in order to increase the early warning lead time. So the data that we're using, we had weekly malaria data for 148 districts in Mozambique, which you can see on the right here, spanning from 2010 to 2017. We compared this with climate data, which included precipitation, sea surface temperatures, other things like wind and temperature. And ultimately, the crux of this analysis, after doing some quality control on our data and pre-processing, was an empirical orthogonal function analysis, or EOF, which identifies patterns of shared variability. And what this looks like, you can see on these results here, where we have our two dominant patterns of year-to-year variability of malaria. On the left here is our dominant pattern. And anytime you have dots here, each dot represents a district. If there are two dots that are the same color, particularly if they are very intensely the same color, their rates of malaria tend to vary together over time. And so you can see this pretty strong cluster over the central and southern part of the country. And this pattern explains about 64% of our year-to-year change in malaria. On the right, you can see the secondary pattern, which explained about 17% and was focused primarily on the northern part of the country right there. Ran similar analysis on precipitation, which you can see right here, very similar clustering. I'm not going to go into it too much right now, but ultimately we tied that first pattern of year-to-year malaria variability, which you can again see on the right here, to the El Niño Southern Oscillation. So we see during a La Nina, compared to an El Niño or neutral phase, we see much more precipitation over that central and southern part of Mozambique, which mirrors very nicely what we saw in the malaria EOF. We also tied our second pattern to a more regional mode of climate variability called the subtropical Indian Ocean dipole. Ultimately, we think that this information on quasi-predictable climate phenomenon could help enhance early warning systems by increasing actionable lead time. If you're interested in more, feel free to check out our publication, which came out early this year. You can use this QR code right there to scan to it. Thank you very much.